So welcome back to this episode 2 of the series tutorial on web scraping with BeautifulSoup library. We will dive into functions provided by the BeautifulSoup object that help us to explore and extract data from web pages. Let's jump right into JupyterLab and begin to navigate web page structure to extract data from the web. So we will start by using the static HTML document that we illustrate with in the episode 1. So this is the kind of text you get when you send an HTTP request to get the the structure of a live web page. So we want to use this as an illustration so that we will understand the concept of functions of BeautifulSoup library. So by using this, we will illustrate those functions, then we can now use this knowledge on a live web page. So we have this static HTML document, and now we need to import the BeautifulSoup library. So we say from BS4 import BeautifulSoup. So after this import, this is capital B. After this import, then we can create a object by saying BeautifulSoup. Then it needs 2 arguments, which is the text structure of the web page, which we have assigned to a variable here, and we'll pass it using HTML parser. So having this, we'll have the soup structure, which we can verify by printing this pretty file. So having got the soup object structure of the web page, let's look at the construct, the BeautifulSoup construct that help us to navigate the structure of this web page. Firstly, it's the title. What's the title of this web page? What is the title tag? Let's look at the title tag. The title tag, we have the soup.title. So this gives us this display to us the tag that is the title tag of this web page. You can see the title tag is this. So if you look at the structure that we have here, we have given the title tag. This is the title tag, and we can get this the string within the title tag. We can get the string within the title tag by saying soup title dot string. This provides for us a navigable string. This gives us a navigable string. If we assign this to a text, let's say navigable string, we say we want this assigned to it, so we can check the data type of this navigable string by saying print type. So if you look at this, you see is a BS4 element, is a BeautifulSoup element. So if we want to extract this into a string variable, Python string variable, we will use another construct of BeautifulSoup, which says, let's say this is a string variable, and it will be soup.title.getText. So this returns a string. This returns the embedded string of the title as a string Python string variable. So if we look at this class now, string var, we can see the type is class string. In episode 1, where I introduced the document object model of a web page structure, as I mentioned that the elements of a web page structure include the text that is embedded inside the tags. So this first statement, which gets the string, the navigable string, actually return the string within the title tag as an element of that structure, as also an element of the structure. We mentioned that the string embedded in the title in the tags are actually the leaf node of the structure. So this returns the string as an element of the structure of that web page, and that's why you see the class is a BS4 element, which is a navigable string. And this second method, this is a function that actually returns the text inside this tag as a Python text string variable. And that's when we inspect the type, we can see that it is a string type. We can also look at the title tag. What is the parent tag of the title tag? I showed you the DOM structure of the HTML framework in episode 1. So what is the parent tag of the title tag? Let's check by using this construct, soup.title.parent. So parent tag of this title tag is the head tag. We can actually get the name of that parent tag by saying title.parent.name. You can also check the p tag. We can look at the first p tag in the soup with this construct soup p. Let's look at the first p tag in the soup. So you can see first p tag here. When we go back to the structure, so this is the first p tag in the soup, this, which have a b tag inside it. You can see it. So this is the first p tag, and we can actually check the attribute of the class attribute of the first p tag. We say p class. So the class attribute of the first p tag, you can see, is title, is assigned title. We can also look for the first a tag in the structure. We say soup a. Look for the first a tag in the structure, and you can see the href attribute of this a tag has value tunji.html. We can look for the href attribute of this first a tag with this construct href attribute of the first a tag. You can see it gives us tunji.html, and as we are checking this, you see that it picks the first a tag. But if I want to see all the tags, all the a tag in that HTML structure, I say if I want to get all the a tag elements in the soup structure, it will say soup.find all, find all a. Let's see it. And you see all a tag is returned in a list. You have all the a tags in a list. So that is the construct to find all the a tags in the soup structure. If you look at the the structure of the HTML, as we have list elements also, so we have 3 of them. So it's the construct is able to find all the a tags for us and return it in a list. We can assign this return into a variable. Let's call, we have all a tags is equal to soup.find all a tags, right? And you have this in a list, and if you look at this a tag, it's going to be a list of the elements, a list of the elements. You can see is a list of the elements. We can actually iterate through it. We say for tag in a tags, we want to print, this is tag, right? We want to print tag. So you see you have all the tags here. We might want to even print all, just the href. You can say get print all the href for the tag. That is the link within that tag, this enclosing bracket. So we can see the link within the tag. Each of the tag is printed out here. So to achieve the same thing, you can also use tag.get href. It gives the same output. So if you run this, it is the same output. Similarly, like as this, we can get all elements within the structure of the soup. You can also get all the text elements in the soup. So you can say get text. Like I have introduced the document object model in the first episode. You can see that text is also element within the structure of the HTML, which are the leaf nodes of the structure, which we are usually often the leaf node of each of the structure. Let's look at all the text that we have here. You can see text. Here is introducing my family. There is a beautiful family, and their names are Tunji, Kenny, Tunji's wife, David, Shemi, and Timmy, and it is to be continued just for the example HTML structure. So this statement gets all text elements within all tags that we have in the soup structure, in the Beautiful Soup structure. So we have seen how to get any tag within the soup structure. You can get any tag. We can even get the B tag. Let's say the big tag. You see the big tag, and you can get the text within that big B tag, the text element within the B tag. For example, you can say get text. So this will give us the text within B tag, and if we just run get text on the whole soup, it will give us all the text within the soup structure, within the HTML structure. So we can get the tag. We can even get the tag name. Let's say we want the tag name. We have this tag name. Another Beautiful Soup construct that we can use to explore the HTML structure is the attributes. Of the tag, the tag's attributes. Let's look at what this implies. So exploring the attributes of each tag. So for example, let's look at the soup structure again. Let's print soup. That's prettify. So we'll see the structure. We can see that some of this tag has attributes. Let's look at the A tag, and let's pick the first A in the structure. Picking the first A tag in the structure, we'll say first A tag. Let's assign it to the variable first A tag, and we have soup.a. So let's look at this. And if we print soup.a, let's look at what soup.a looks like. You can see it's a tag that has different attributes. Now let's look at the attributes. Let's print all the attributes. First A tag dot attributes. So the dot attributes. So you can see we have this attribute returned as a dictionary of where the attributes itself are the key of the dictionary, and the value assigned to that attribute becomes the value of the dictionary. You can see the href is a key, and it has a value tunji.html. Then class is a key which has a value family, and id is a key which has a value so if you observe this output very well, you can see the dictionary, some of the values. For example, the value of class is a list, and so that means this particular attribute can have multiple particular attribute can have multiple values. It can have multiple values. So HTML define a few of attributes that can have multiple value. The common multi-value attribute is a class. A class can have more than one value as it's as assigned to it. So a tag can have class attributes with multiple values, and these kind of attributes are the ones that are returned as list. So you can see the class, the attribute class is a multi-valued attribute of the A tag. So let's look at the P tag. Let's look at the P tag. Let's look at the P tag of the soup.p, the first P tag now. So let's see what we have in the P tag. So you have this P tag with attribute class assigned title to it. Let's now check with the attribute construct what is the attribute returned for P tag. So p.add. So you can see that it returns the attribute class, and it returns the value as a list, though it has only a single value in there, which is title, but it tells us that that attribute class can have multiple values. Another attribute of Beautiful Soup object that we can use to explore our HTML structure and content is what we call contents. For example, for a tag, let's capture the head tag of this Beautiful Soup. Head tag is equal to soup dot head. So if we look at the head tag, we can see the content is the title, which is introducing which has another string element introducing my family. If we check the contents of the head tag, it will return this for us, which includes the next line element. So this next line element is also this next line. Tabbing the title to next line is taken as a next line element in the HTML structure. So we can filter this by saying let's assign it to filtered head by saying we want all elements in the list for elements that is in the head tag contents, if that element is instance, so element is instance of navigable string, and when we strip the element dot strip is going to give us an empty string. So we don't want this, so that's why we say this is true. So if it is an instance of a navigable string, but when we strip it, it becomes empty, so we use this not to negate it. And using this, we need to import the navigable string library. So from bs4 import navigable string. So with this construct, we have been able to filter. So if we check this filtered head, the next line has been filtered, you can see. So the only element we have in the head tag content now is the title tag. So the element, the next line element, which is introduced due to the fact that we tab this, as when we have this, and up here we won't have the next line element there, but because we tab it, the HTML structure see this as also an element, which is the next line element of the HTML structure. So we have been able to filter that out and get actually the content that we want from the head, just to understand that, and it will help to explore our HTML structure. So let's work another example of using contents to the attribute contents to explore the contents of a tag. Let's capture the UL tag in our soup structure. So UL tag is soup.ul, and if we look at the UL tag, you can see the contents. So we have the li content, and we can explore that with using contents. So we can see here too, we have the next line element also as element of the list returned by the UL tag content, just because we have all this tab into the next line. Let's write a function that we can be using to filter this next line out. Let's say def filter next line, and we have the contents as arguments to this. So we can say filtered next line now is equal to, and this will be content. The head tag content now will be content, and I think that's pretty much what we need to change. Then we now return from our function, we return the head tag content. Remember, we have imported the navigable string here, so we can use this method. We can use this method anytime we want to filter the content, and this will be the def method. Let me copy this method. If I copy this and I say ul tag content is equal to this, then the UL tag content will be an argument to this function. And if I print this, if we look at this UL tag content, now you see that the next line has been filtered. So we can use that method to always filter the output of our content attributes of the tags. So similar attributes like the content attribute of the Beautiful Soup structure is the children attribute, children attribute. So you can actually check the children of a tag, like you have the UL tag. Let's see, the UL tag is here. You can say for child in tag.children, you can actually print each child. So this gives us the iterate through the children of the UL tag and print it out for us. It's not actually a list, it's not returned as a list like the content. So if you have this UL tag dot content and you want to get it at a list, you need to actually get list. Let's say get list, you need to actually convert it to list because it's a list iterator, not directly a list. And if you do this, this is children, I want to say here children. So if you have this, you can return a list similar to the content, the dot content. So if you have this, you can have the list just like the content, but if you want to just iterate through it and print it, and you can see that this just print as elements of the HTML. If you say for child in the U tag children, it returns HTML elements, and that means the next line will just give you a space. Let me see, for child in this print child, so it returns like the HTML element, and this will just return a space rather than giving you /n. So it is a returns HTML element, but if you want to get those elements as list, use the get content. So it's a similar construct, get content and dot content and dot children of a tag. Another useful attribute of the BeautifulSoup element is the attributes descendant. So these attributes, unlike the children and the dot contents attributes that lets us get the direct children of a tag. For example, we have the head tag, which gives us soup.head, and for the head tag we can say the head tag dot contents. So that gives us the title tag, the head tag dot contents. That gives us the title tag and the next line elements we showed the other time. But there is still other elements here, which is the string element, which is a child of the title tag. So if we use descendant, if we say head tag dot descendant, we will see that it will give us the title tag, the next line, the title tag, the next line, and also the children of the as the children. So let's run this descendants. Let me say for D in descendants, so because this is a tag descendant, so we can say print D. So if we look at this, we see that the first descendant is the title, the second descendant is the string. There is still a space, the space is still there, the next line element is still there as the descendant, unless we filter this. So we can get this descendant as a list also. Let's say head this, let's call it a list of head descendants. So we convert this to a list and we can print it head descendant. So we'll see what it comes. So that's a kind of list that contains the next line, the title, and the string within the title. So it's the descendant attribute gives you the children of the tag and the children's children and the children's children. Let's look at the UL tag. The UL tag has us, we have soup.ul tag. Let's look at the content of the UL tag. We have the UL, the LI, and the LI. So inside the LI tag also we have this string Tunji, this string Tunji's wife, this string David, Shemi, and Timmy. So if we use the descendant, we can say UL tag descendant. So let's call it tag dot descendants. So if we look at this, we will see, and ul, let's just view the list. This converts this to list. Let's convert this to list because it's a list iterator. Let's convert it to list, and we can have it view as a list here. So you can see it has the next line tag, the li, and the a tag inside the li tag, and also the Tunji string inside the a tag. So it gives us the children of that tag and its children's children. So you have the descendants displayed there. So the content attributes children attributes and descendant attributes are exploring the HTML structure tree down, and we can also explore this structure tree up. For example, if we have, let's say we have the head tag, which is soup.head. You can see if we view the head tag, you see that we have the title tag inside the head tag. So we can capture the title tag. Let's get the title tag. So the title tag is shown now as a child of the head tag. Let's see the title tag. The title tag will be the soup.title, and we can look for the parent of the title tag dot parents. So if we look for this, then it gives us the head tag. It shows us the head tag. So we can explore up, going up. So we get the title tag, which is the parent of the title tag, which is the head tag. We can actually look for the name of the parent of the title tag, which is the head. So let's look at, like for example, let's see the ul tag also. So ul tag again is a soup.ul. So if we look at the ul tag, we can see it has children li tags. So, and it has more than one child. But if we let's take the first li tag, soup.li, that's first li tag. Let's assign that to that variables. Let's assign the first li tag to that variable, and we can look for the parent of this first li tag, which is dot parent. So which gives us also the ul tag. We can look for the dot parent name, which is called the ul tag. So you can see the li tag as parent ul tag. We can look for the a tag. Let's look for the first a tag, which gives us soup.a. and if we look at the parent of the first a tag, parent of this will be li tag, will be an li tag, and we can just get the name of that tag, which is li. So that is a way to go up the ladder of the HTML structure tree in using BeautifulSoup attributes. We have explored the descendants down. We can explore the parents up using, instead of using parents alone, let's say the first tag, the first a tag, sorry, and we want to explore the parents, and that will return a list for us. Let's say list of parents, and we say it's converted to a list because it's a general list iterator. So let's say list of parents, and if we look at this for elements in list of parents, then we can say print elements.name. So we want to print elements.name here, or print elements.name. So what are the list of parents in the li tag? So from the a tag, right? So the first parent is li. You can see inside the first a tag has the first parent li, the second parent is the ul tag, the third parent is the p tag, the next parent up there is the body, the next one up there is the HTML, then we have the whole document. So that's the generation of parents that encapsulates the first a tag. So the .content.children .descendants explore the HTML structure downward. We can use the parents to explore the HTML structure upward. We can also explore the HTML structure sideways. We can explore it sideways. Let's say sideways. So we can look for the same the elements, the children of the same parent, the children of the same parent, that is the siblings. Let's look at the ul tags, or ul tag again, and capture the soup.ul. So in this structure, let's view the structure of the ul tag. You see that we have three li's, which are direct children of the ul tag. So these are siblings. So we can look for the first li tag. First li tag in the ul tag. Within the ul tag will be ul tag dot li, and if we print this, we can see it's the first li tag with the string Tunji. So we can use this to navigate all the siblings within the ul tag. So the next sibling, because this second li tag is tabbed to the next line, so the next sibling will be just the next line element of the ul tag. So let's say the next sibling will be the next line element, and we can look at the next to that one. Next sibling to that will be the next li, and if we use next sibling again, right, we will have the next line again, and the next sibling again will give us the next li, which is having David Shemi. So that's the last one. Let's see what it will give us if we explore further the next sibling. This should have none. Next line again, then we have the next sibling, which should have none. So we have no sibling anymore. So it captures all the li, but it includes the next line element, because we tab it to the next line, and that's the normal structure to give to produce a clear HTML structure. Furthermore, you can go back and forth in the navigating the tree structure of the HTML using the BeautifulSoup object with the attributes next element and dot previous element. So with these attributes of BeautifulSoup, you can go back and forth the HTML tree. So let's look at the head tag. For example, we have a head tag which is equal to the soup.head, and we can look at the next element of the head tag. Next element, this could be the next line element, I suspect, we can look for the next element of this, so which is the title, element. We can also look at the next element of the title. Next element of the title tag will be maybe the introducing my family, which is string, which is the string element. So we can also navigate back using previous element, which is the title, and also navigate back again using the previous element will be the next line element, and we can use the previous element also to get back to where we started, previous underscore element, to get back to where we started, which is the head tag. So you can see we can go back and forth on the HTML document object model tree, using this next element, previous element attribute of the BeautifulSoup object. So summarily, we can navigate and search for a particular element within the tree structure of a web page that has been passed into a BeautifulSoup object. So we have seen different attributes of the BeautifulSoup object that helps us to navigate the tree, and also we've seen the attributes such as find all in action that helps us to filter the structure based on a string value. So now with this construct, we are looking for all tags that are as B tags, all B tags in the structure. We can also use a regular expression. For example, we want to say import a regular expression object library, and we will use that for here for tag in soup dot find all. So I want to find a tag that contains the element that starts with the letter B. I want the tag that starts with the letter B, and so if this is true, then you print the tag name. Let's see what this gives us. So we have this. If I run this, you can see the tag body and the tag B starts with letter B within the structure of our soup. Also, we can say for tag in soup dot find all, using the regular expression compile, we can say we want tag that starts with the letter T. We want a tag that starts with letter T, and when you get that tag, we want to print the tag name. So you see this prints the HTML tag and the title tag. Those are the tags that start with letter T. You can also filter with list. We can say we want tags A and B tag. So we want soup dot find all. Then we will use a list of the letters that we want to search for. So we want the A and B tag. The A and B tag. If you run this and let's print this tag, let's view this tag, so we can see we will have all this is the B tag that we have in the structure, and these are all the A tags that we have in the structure. We can also capture all the tags that we have in this soup structure. We can say for tag in soup dot find all. Let's use the true, and we say print the tag name. So we have all the tag name of all the tags that is contained in this structure: the HTML tag, the head tag, the title tag, body tag, P tag. So these are all the tag name that we have in this structure. So we can also filter or search for a particular element within the structure by using the attributes of the tag. For example, let's say we want to have a tag with link. So we want to find within the soup structure, find all tags with the attribute ID equals to link 1. Let's see what this gives us. If we run this and we say tag with link, we can look at what the output is. You can see all the A tag has an ID link 1, so it returns all the tags that have ID equals to link 1. So in another example, we might want to return all tags that has the string 20 embedded therein. So for example, we can say tags with string 20. We want to have soup dot find all tags lambda. We use lambda tag dot string, and 20 is in the tag. So let's look at what this gives us. So if we print these tags with 20, we'll see all tags that has that string, and you see, so these are all tags that has the string 20 therein. So in this episode, we have explored and learned the attributes and functions of BeautifulSoup object using a dummy HTML structure example that is assigned to a text that is assigned as text to this static HTML doc here in this Python script, which allow us to navigate the structure and search and extract data from the structure. In the next episode, we will apply what we have learned here to a live production web page to extract, clean, and present useful data from the website. Don't forget to subscribe to our channel. This encourages us to create more useful and impactful tutorial and ensures you get notification when new videos are released. So also like the videos and share them with others who might benefit from the knowledge we share. See you in the next episode, where we will be exploring a real website to extract, to clean, and present data using BeautifulSoup attributes and functions. See you then.